Hello to all of you. This is Dr. Dhaval Maheta, and today we are going to understand how to run linear regression analysis with cross-validation in Rapidminer. So the cross-validation is a technique for validating the model efficiency by training it on the subset of input data and testing on previously unseen subset of the input data. Let me try to explain this in the next slide. If you consider this to be the data set, we will split the data into testing and training. The training dataset will go for the cross-validation where the parameters will be introduced and it will select the best parameters and it will be reinserted in the retrained model. After this, the model will be sent for the final evaluation where the testing data will be fed to this mechanism. So the evaluation will be done on the test data. Now, if I consider the entire data, and if I split it into the training and testing data. So in test training data also, there will be some folds. We will divide the data in some folds. Normally, we select 10 folds. Now, in the first fold, if I talk about the first fold and split 1, you can see that this green all are the training data and the blue ones are the testing data. In split 2, now the training data will be this and testing will be this. So by doing this, we are able to get the best parameters. Now how we can do this in Rapidminer? Let's try to understand. First of all, let me clear all the results. Let's start with the fresh process. I'll bring the empty cars here. I'll connect the spline here and I'll run it. Now this dataset contains the model of the car, the miles per gallon, the number of cylinders, the displacement of the vehicle, horsepower of the vehicle, D-rate of the vehicle, weight of the vehicle, QSEC of the vehicle, VS means vertical or a straight engine, or AM means automatic or manual, gears, 3 gear, 4 gear or 5 gear. Basically, this is a categorical variable which we will convert with the nominal to numerical operator. This is also known as hot encoding, or it is also known as creating the dummies. Carburetors 1, 2 or 4. I'll go in design mode. Now this particular operator contains all the variables, but I want to select the particular attributes. So I'll go and select attributes. I'll simply drag it and drop it. From here, I'll select subset. Now, the variables which are matter of my interest is horsepower, miles per gallon, weight of the vehicle, gear, number of gears. Kindly refer my previous videos on Rapidminer so that you can understand the flow of the lecture. Transfer it here, apply. Now I will have to set the role. It means that I will have to specify which is my dependent variable and which is my independent variable. So for this, I'll go in this attribute, select miles per gallon and make it sure that you label here. The target role is labeled. Then only you will be able to run regression analysis. The next thing which you have to do is conversion of nominal to numerical. This is necessary because we are having one variable, gear, which is a categorical variable. This nominal to numerical operator will convert it into numerics. When I'll press the play button, you will come to know what it does. It creates 3 variables, 4 gears, 3 gears, and 5 gears. I'll go in design. This time, I'll go and select attributes. Again. Now, why it is necessary? Let us try to understand. The variable which we have converted into numeric. Let me say, keep this breakpoint after. Let us run it. So, 3 gears, 4 gears, and 5 gears are there. Now, if I enter all these variables together into the regression analysis, there is a problem which will be created, which is known as a dummy variable trap. And therefore, it is necessary that we drop one of the hot encoding. So normally, the lower one or the higher one is dropped. Either the 3 gears or 5 gears will be dropped, because whatever we drop, it will become the benchmark, and from that other comparisons will be made. And that's the reason we go again for select attributes. Now remove the breakpoints. In select attributes, do the subsetting. Select 4 gear, 5 gears, horsepower, MPG, and weight. Transfer it. Apply. Now we want to do the cross validation. Normally, we keep number of folds as 10. But first of all, let's try to find out cross validation. I'll drop it here. Remove the spline at present. Now, when any operator is having 2 layers, it means that there is a parent process and then there is a child process. When you will double click it, you will go in the child process. So I'll double click it. You can see that the screen has been divided into training and testing data set. Now activate the linear regression from here. Drag it and drop it here. Train to train, model to model. The next thing which you have to do is apply the model. Drag it and drop it here. Connect model to model, testing with unlabeled. Now I want to evaluate the performance. Make sure that you activate the performance related to the regression. Drag it and drop it here. Connect label to label and performance to performance. An example to test. In performance operator, don't forget to take squared correlation. Basically, it is a coefficient of determination, also known as the explanatory power of the model. Once the connection of the child processes are complete, press this up arrow and you will come in the parent process. Now there are some connections which you will have to do here also. From model to result. From performance to result. From test to result. When you will click this operator of cross validation, you will come to know that there are 10 folds. This is exactly the same thing which we had discussed in the theoretical part. Sampling type, you can keep shuffled sampling or stratified sampling. Normally, we should keep automatic sampling. Now let's run the processes. Run. So you'll get the performance vector, linear regression. And you can see here that all the significant variables have been given the star codes. Star means the significant variables. 1 star means significant, 2 star means moderately significant, 3 star means highly significant. But it is also displayed the result of gear 5, which is completely insignificant because its p-value is more than 0.05. It means that it is insignificant at 5% level of significance. Here, the desirable value is it should be less than 0.05. Then only these variables are contributing towards the dependent variable. If you go in description, you will get the entire equation. But you are also getting the variable which is insignificant. I don't want this. So from where I can do this? I'll go in design. I'll double click on it. I'll go in linear regression and I'll make sure that I'm on the t-test. So all the insignificant variables will be dropped. Press the play button. When you will come in the linear regression, you can see now, you will get a clear cut those variables which are only significant. Go in description, you have got the equation. Kindly refer to my previous videos on linear regression, how to interpret this. I have already discussed that. If I talk about the performance vector, root mean squared error will be displayed. Squared correlation is the explanatory power of the model, which is also displayed. Now you can go in visualizations to see how much the prediction is with the actual data. So I'll activate the MPG, I'll activate the prediction here, and I'll make sure that I'll pass a linear regression line from it. Okay. When I click on result history, it will give me the summary chart also. For more videos on Rapidminer, kindly subscribe to my channel. You can follow me on LinkedIn and Twitter. Please see my playlist for more videos on Rapidminer. Thank you.